Here we are for another video. Now we're going to do a test on the fish. We have some freshly bought fish here. What kind of fish could it be? We have some nice red mullets, two beautiful red mullets, fresh as can be. So let's put one here in this bowl and one in this other bowl. In this bowl, we're going to add a special kind of water, specifically water that's rich in molecular hydrogen, so it's an antioxidant water. But before doing this, I want to point something out to you, something I really recommend for those who work in the restaurant business or even at home. If you have this device also dispenses an acidic water with a pH of 2.5, which comes out of the small tap at the bottom. As you can see right now, I'm pouring this water here. I'll just leave it for a few seconds because this water is capable of eliminating any spores as well as viruses and bacteria that may be present on the outside of the fish. So once I've done this, I move on to hydrogenating the fish, making it antioxidant as well, because we'll see that fish meat actually undergoes a process of oxidation that is much faster than even regular meat. That's why it's important to counteract this process using molecular hydrogen. Here we are carefully dispensing regular tap water specifically in order to meticulously make this comprehensive comparison between the various different ways of effectively cleaning fish in water. So in this container, we prominently have the standard tap water, and over here in this other container, we clearly have the antioxidant-rich water. Now, the crucial question is, how exactly can we definitively tell if this particular water is oxidizing, or conversely, if it is indeed not antioxidant at all? Again, we use our ORP meter. As you can see, it says ORP meter here, so we're going to measure the oxidation reduction potential. In tap drinking water, this potential is always positive, also because of the chlorine, which has an oxidizing effect. But this water, on the other hand, is antioxidant water, as you can see. The value even goes to -500, -600, which is incredible, and that's thanks to the presence of molecular hydrogen, which I can confirm for you with this other device, an H2 meter here. We turn it on, and as you can see, it reads 0I. Hope you can see that. I think you can, okay, it reads 0. But here, in this other water where our red mullet is, it's becoming fresher and fresher, more and more antioxidant, so it's really undergoing an anti-aging process. The quality of this process actually affects the fish itself, because I assure you, the fish acquires a totally different flavor compared to this one and to the one washed normally with water. But how can we also tell if the flesh of the fish hashes become uhis, different compared to the one washed with regular water? So let's take our fish, okay? Let's see. Let's remove C. From the red mullet, I'm trying to take off some of the scales, okay? Until we get to the flesh, MH. Okay? So there was the scale covering it. So, just a moment. Here we go. You see, now I'm putting, because this tip here has a platinum and titanium tip that basically shows me the oxidation state. I go into the fish here. The fish, as long as it's antioxidant, is around 120 to 110, right? Can you see it? I think so, yes, I see it 94. That's perfect. Now let's take the other fish. We'll do the same thing. It's not ideal to do this with bare hands, but that's how it is. That's how this video is turning out. Okay? So I remove the scale. I'm also doing this to keep things consistent, right? For the experiment, and so without any editing or cutting, now I pierce the fish And as you can see, the flesh of the fish is antioxidant, so it has become fresh again, just like it would be if it were still alive, like a freshly caught fish. And as I mentioned earlier, this also affects the taste of the fish. Any fish that is treated with antioxidant water takes on truly incredible flavors. In my experience, I can tell you that sometimes even canned tuna, which is extremely oxidized, here we had an oxidation level of 120 to 130, and canned tuna is always a bit higher, but when we apply this antioxidant process to fish, whether it's fresh, preserved, or anything else, even in salmon, everything takes on an incredible flavor. Chefs who are familiar with this antioxidant cuisine truly give it credit and value all of this. This means having a completely renewed revolutionary cuisine, true revolution, happening within the food itself. I don't go looking, let's say, for fish from that particular place we know is good and fresh, etc. But this process actually improves the quality of any type of fresh fish or even canned fish. So it's a significant difference you get when dealing with molecular hydrogen and its antioxidant action.